Good evening, dear students. Now, welcome to the ACE Online and ACE Engineering Academy. Coming to myself, myself Gnaneshwar. Here, today's session. Okay. GENCO. Now, coming to the today's session, TS GENCO for AE post. Now, revision session. We are going to discuss now what is the subject here. Now, today's session is TS GENCO AE. Coming to the subject, we are going to discuss now control system here. Control system is a, for GENCO point of view, it is a very interesting subject, scoring subject, as well as scoring as well as interesting subject, and it is a limited syllabus. Approximately you are getting around 10% marks weightage in the TS GENCO control system. Now coming to the control system syllabus in the GENCO paper, what is the according latest syllabus copy? There is no big changes as compared to the previous. Why? Because same topics for control system. Now for all either GATE or GENCO or IES, same topics only. Now once again, what are the topics mentioned here in the GENCO? Basics of control systems. Now basics of control system. First I am going to discuss the syllabus. Later in detail we will discuss one by one. Block diagrams mentioned and also signal flow graph dears. Signal flow graph in the control system syllabus. Now time response analysis. From this topic compulsory one question. Compulsory one question from the time response. And one more chapter is Routh-Hurwitz stability. From here onwards, stability analysis is going to start. The main purpose of the control system is to find the stability. So stability start from here onwards. Routh-Hurwitz stability and one more stability method here. Now one more stability method is root locus. Here root locus. These two are the time domain methods. Routh-Hurwitz as well as root locus are the time domain methods. Now coming to one more chapter is the frequency domain methods for the stability. It's no doubt in the frequency domain, first one Bode plot, then we can find the stability. Polar plot, it is also frequency domain method to find the stability, and Nyquist plot here. So these three are the frequency domain. Where about the previous Routh-Hurwitz as well as root locus are the time domain analysis. Then we have the syllabus state space analysis, then last compensators and controllers here. Compensators and controllers, everything is included here. Now this is the syllabus for the control system, control system for GENCO. Now weightage. If you observe the previous papers, what is the weightage here? We'll observe now from last TS GENCO. Here 6 question, TS Transco 8, SPDCL 6, now NPDCL 7, SPDCL, now GENCO TS Transco 2018 12 marks, 12, SPDCL 10, 7, 8. So on an average we are getting around 10% weightage. Getting 10%, around 10%, and it is a scoring subject. It is a scoring subject, interesting subject, as well as limited syllabus. It is an independent subject. There is no link to the other subject here. Directly, there is no link to the other subject. Directly, you can get the marks easily here. You can score easily. This is the weightage of the GENCO Transco. Now, GENCO paper. Previous Telangana state, all the exams weightage here. Now, syllabus completed. Let us textbooks. What are the textbooks is required for the control systems? Now first one, Nagarath and Gopal. It is a standard textbook. Now second textbook is a medium, Norman Nice, and next one is Ogato. So these are the standard textbooks for the preparation of the competitive exam. Now cover pages here. Now Nagarath and Gopal, Nice and Ogato. These are the textbooks for reference here. Now next one. Yes, I'll start with one motivation here. Before starting the subject, I'll start with one good motivation here. Now, dear here, the struggle you are in today is, the struggle whatever you are today is the developing the strength you need for tomorrow, dear. So whatever you're preparing morning to evening, even your pain, back pain or neck pain, or morning to evening psychologically, physically, and also financially you're facing lot of problems at the time of preparation of GENCO, I know. So don't worry dear, the struggle whatever you are in today is the developing the strength that you need for tomorrow. So in between, don't stop, dear. So don't stop. So don't give up, dear. This is the best motivation quotation I'm starting with the best motivation quotation. Now with this one, I'm going to start our control system syllabus here. Okay. First one. Yes, basics of control system. In the basics of control system, in the state level exam, what are the questions they are asking? Mainly focusing. First one, transfer function here. Transfer function. So transfer function means examiner may provide that transfer function is nothing but Laplace transform of output upon Laplace transform of input. So this formula I am going to write here. What is the formula for transfer function? Equal to Laplace transform of output upon Laplace transform of input. This is a formula, dear. First starting, this is the first definition. Second definition for the transfer function, Laplace transform of impulse response here. Okay, based upon this one, examiner is asking questions. So transfer function, the state level exam questions are asking. And second topic here, no doubt, open loop control system. So what is open loop control system? And second one, what is a closed loop control system? Mainly they are focusing the comparison between the open loop and closed loop. Okay, in which one bandwidth is more, in which one is gain is more. Okay, parameter variation is, what is the comparison between the open loop closed loop system they are asking. Now next to sensitivity analysis. Sensitivity analysis mainly sensitivity analysis for open loop system here. Now sensitivity for open loop system we'll discuss here. For open loop system sensitivity is 1 D here. Open loop system sensitivity is 1 no. That is 100%, very high. Very, that is the biggest drawback. Very high. So sensitivity means any changes in the input, very big changes in the output. That is the sensitivity. Any parameter changes. Now in the closed loop system, again closed loop system there are two here. Sensitivity with respect to parameter variation G. Parameter variation G. The formula here 1 by 1 plus GH. So variation should be always less. It is a less than 1, so advantage. And also one more formula with respect to this parameter with respect to open loop transfer G. Next parameter variation with respect to feedback factor H. So that formula is minus GH by 1 plus GH. These are the mean summary. It is also less than 1. So in the closed loop system, sensitivity parameter variation is very less as compared to open loop system. So these are the main topics here. Now, okay, with this topic, we'll discuss some of the expected questions from the GENCO point of view. Come on, you have to respond, you have to motivate. I have to motivate you people, you have to motivate. Come on, along with me respond. Now, I'll go for the one previous question here. First question, the transfer function of a system is this one. The impulse response of the system is asking. Just now we were discussing this question. A transfer function is nothing but Laplace transform impulse response. Impulse response equal to inverse of transfer function. That is the formula we need to use. So transfer function is given here. Transfer function is given now. So what is given here? Now transfer function is given. Now impulse response equal to impulse response. Formula for impulse response equal to now impulse response IR equal to inverse of L inverse of transfer function. Before finding the transfer function inverse, let we find the partial fraction. That is a better. Let we find the partial fractions here. Now partial fraction means given transfer function equal to 1 upon s plus 1 product of s plus 2. Then if you apply the partial fraction, something a by s plus 1, so plus b by s plus 2 dn. Now come on, help me here. What is a value, b value? You know simple mathematics here. To find the a value, substitute s is equal to minus 1, except this one. Substitute s equal to minus 1, minus 1 plus 2. So minus 1 plus 2 means a equal to, no doubt, a equal to how much? Come on, tell me, 1 only. Now to get the b value, here, now to get the b value, substitute s equal to minus 2, except this one, s equal to minus 2 plus 1, minus 1. So b equal to minus 1 here. So transfer function we got it. What is the transfer function equal to? Transfer function equal to 1 upon s plus 1 minus 1 upon s plus 2. So we know impulse response equal to, according to definition, impulse response equal to L inverse of transfer function. L inverse of transfer function means L inverse of 1 by s plus 1 minus 1 upon s plus 2 dear. L inverse of. Now help me. 1 by s plus 1. Impulse response equal to. Already we know the basics here. What is the basics here? Now some basics we'll discuss here. Let us the basics here. I'm writing the basics here. Now okay. Now you know very well the basics here. L inverse of 1 upon s plus a equal to command here e to the power of minus at. Here plus means you will get minus here. Now tell me here e to the power of minus. Now s plus 1 is there. Na? S plus 1 means e power minus 1t. This original minus sign e power minus 2t dm. So obviously what is the best suitable answer here? Obviously option D is right answer dear. Option D is right answer. Come on, you have to give the response here for this one. Yes, from transfunction impulse response based upon this one, examiner asking questions here. So I have selected one question here. Now next one more. Yes, the open loop transfunction is given. The poles of the closed loop system is asking. Now you know this open loop system is asking. Given solution is, what is the closed loop transfunction? Tell me. Closed loop transfunction equal to g upon s by g of s by 1 plus g of s h of s. S do it. Now g of s is given. H of s is nothing but unity feedback is given. Unity feedback means h of s is 1 dear. So substitute all this one, then you will get the answer 1 upon s square plus 2s plus 1 dear. That is a closed loop transfunction. And we can write closed loop transfunction as it is a perfect square 1 by s shall I write s plus 1 whole square. Denominator parts are called as a poles dear. Closed loop transfunction we got it. Denominator part is called as a poles here. So what are the poles here? Poles equal, tell me, poles equal to denominator part poles here. There is a s square term, so s equal to minus 1 and one more because of square minus 1. So no doubt option C is perfect answer. Come on, you have to respond here along with me. Yes, Arik. No one is responding. Come on dear, okay, respond along with me. Yes, very good. Thank you, Ishwar. Sir, your teaching is mind-blowing. Okay, this type of motivation is required, Ishwar. And Omkar Ishwar, sir, RH criteria is absolute stability or relative stability? Yes, Omkar Ishwar, your answer, in your question only answer is there. It is the best to find the absolute stability. RH is the best to find the absolute stability, but it is not best to find the relative stability. Hence we decide RH is best to find the absolute stability. Very good. Ishwar, okay. Thank you, Ishwar. Okay, your motivation. Now, next we are positive feedback. Okay, fine. Next we'll move to the one more question here. Yes, Rami. Okay, thank you. Now you have to respond here. One more question. Yes, very good question. This type of question you can expect in the TS GENCO. Now come on. Try to open loop system converted into closed loop system. Then what are the, if you convert open loop system into closed loop system, what are the modification, what characters are going to change? So open loop system, closed loop system comparison we required. So let us, this is open loop system there. Open loop system, this is open loop system, open loop transfunction, open loop system. It is a closed loop system. Now closed loop system. Now we'll discuss. I'll show the options once again. I'll show the option once again. Come on. Yes, these are the options dear. Very good. Students are responding nicely. Monica, Omkareshwar, super, super. Omkareshwar and Monica. Very good dear. Yes, your answers are correct. Very good. Now we'll move to the connections here. Now, open loop system transfunction, open loop gain. Tell me open loop gain equal to G dear. Closed loop gain equal to closed loop gain or closed loop transfunction, closed loop gain equal to with a negative feedback by default g by 1 plus gh. Now tell me, as compared to this is shall I write g by 1, this is a g by 1 plus gh, it is a less than 1 only. So closed loop gain is less than 1, it is a less. So closed loop gain is less only. Gain is less, we can write, if convert open loop to closed loop, gain is more here. This is a gain is more in the open loop, gain is more, gain is less. So what is the overall gain is increased. If open loop is converted to closed loop, is it gain is increased? No, gain is reduced here. Gain is reduced means it is wrong here. This is a wrong here, dear. Gain is increased is wrong. So this is a wrong statement, wrong. Gain is decreased. If open loop is converted to closed loop, then gain is decreased. Now bandwidth is reduced is asking. What is the bandwidth dear? There is a one formula. Gain bandwidth product always constant here. Gain bandwidth product always constant here. So in open loop system, gain is more. Gain is more means bandwidth is less. Bandwidth is less in open loop system. Bandwidth is less in open loop system. Where about here gain bandwidth product equal to? Come on. Gain bandwidth product equal to constant here. Gain bandwidth product equal to constant. According to this rule, now in this one open loop closed loop system gain is less. Gain is less means bandwidth is more in the closed loop system. Bandwidth is more. Bandwidth is more. If open loop is converted to closed loop, bandwidth increases only. But bandwidth is reduced is given. Reduced is wrong dear. Reduced is wrong dear. Bandwidth is this is also wrong. It is increased. It is also wrong statement. Wrong. Okay. Reduced. Now disturbance reduction capacity. Now what is the parameter variation is reduced. That is okay. Okay. Here in the open loop system, first one I can write, let us now sensitivity more sensitive na? Here more sensitive. Sensitivity is one na? More sensitive to with respect to parameter variation, very less sensitive with respect to parameter variation, less sensitive to parameter variation. To parameter variation, anything changes, very less effect on the system, very less. So parameter variation is reduced. It is a correct statement. Disturbance reduction capacity is reduced. No dear. Here more disturbance here. Where about in open loop system, disturbance is more. Here disturbance is more. But in the closed loop system, disturbance reduction ratio is reduced. Is wrong statement here. This is wrong here. Disturbance capacity is increased in the closed loop system. It is also wrong dear. This is also wrong. So obviously option C is correct answer dear. Option C is correct answer. Now you can check it. We can check it dear. No dear, disturbance rejection capacity dear is not asking disturbance. Elimination, whatever the disturbance is present, that elimination is more in the closed loop. That elimination is more in the closed loop, Omkareshwar. Disturbance rejection. So whatever the noise is present in the open loop system, noise present in the closed loop system. But removing capacity in the closed loop is more dear. Omkareshwar? Yes, fine. Then we'll move to the one more question dear. Okay. Open loop DC gain of the system is given. Examiner is given closed loop system, is asking open loop system gain here. So if open loop is given, how to convert closed loop we know. But how to convert closed loop to open loop? Open loop trans function equal to the shortcut simple formula here. The simple formula here. Closed loop open loop trans function equal to simple technique. Closed loop trans function minus 1 minus closed loop trans function. If you use this formula, then you will get the answer open loop trans function equal to open loop trans function, directly substitute this formula. So you will get the s plus 4 upon s square plus 6s plus 9 dear. Is asking DC gain. Examiner is asking DC gain here. Observe. For DC gain, substitute wherever the s is there 0. For DC gain, substitute in the place of s 0 dear. Substitute in the place of s 0. Substitute in the place of 0. S equal to 0. So what is the answer? We will get 4 by 9 dear. So this option C is perfect answer. Now check it. Yes, Omkareshwar, you are accepted. The reading rejection ratio. Okay, very good. Jayasri. Wow. Jayasri, you gave answer 4 by 13 dear. No. 4 by 13 is correct for exam that is given. It is a closed loop transfunction. Closed loop DC gain, okay. Hello, Monica, Monica correct. Jayasri. Jayasri once recall. Yes. Durga Prasad. Wow, good, good, very good. Super. Yes. Next. These are the question here. These are the types of questions are going to ask in the basics of control system. Next to block diagrams. In the block diagrams only we have the one model. In the regular classroom, I gave the one shortcut technique. If you follow that shortcut, you can solve both block diagram as well as signal flow graph. I'll show the shortcut in the signal flow graph. Now let us one question here. Examiner is asking C of S by R of S. C of S, this R of S is asking. Overall again, how to find out the C of S by R of S here. In the regular class, I gave the shortcut technique, beautiful technique here. Now, how to solve this type of question here? If you follow like engineering college method, block diagram reduction technique, it takes a lot of time. So we have the shortcut technique. That shortcut is helpful for both block diagram as well as signal flow graph. Now let us. Now what is a here simple technique here? C by R, overall gain, C by R equal to C of S by R of S. First in the numerator we have tried the forward paths here. What is the forward path gains here? What are the forward path gain? Come on. 1 upon S, product of 1 upon S. Any other forward paths here? No. No other forward paths here. No forward paths, leave it. No forward paths, leave it here. Next in the denominator part, this is the numerator part, forward path. One compulsory. Then we have tried the loops here. This is a one loop here. Starting point, ending point is same. Starting point, ending point is same, loop only. But at the end, in the overall loop, what is the sign is the negatives there. Opposite sign, 1 plus 1 by S into 2, 2 by S. Loop 1 completed. Now one more loop is also there here. One more loop also there here. Now observe one more loop here. Is start from year to year. This is also loop, correct na? In this loop also number of negative signs are 1 here. Number of negative signs are 1 here. So complete loop gain write down. Complete loop gain write. So opposite sign of this minus plus 1 by S into 1 by S. 1 upon S, product of 1 upon S. Now here nothing is there. So that path is 1 only. Leave it. These are the loops dear. After the simplification of this one. After simplification of this one. So what is the answer you will get? After simplification of this one. So no doubt you will get the simplify this one. 1 by S square plus 2S plus 1 dear. Simplify it one. No doubt. So option D is perfect answer. Option D is perfect answer. Very good. Students are responding very nicely, very okay. Speed mode. I think you have done lot of practice. Yes. Sanu. Okay. B. Monica Omkareshwar. No, Monica, you gave D. Only Monica is given correct answer. Or Monica is given correct answer. Now, okay, good. Then this type of question, let us will discuss the one technique in the signal flow graph. In the signal flow graph, what questions you can expect? Same overall trans function by using Mason's gain formula. What are the questions you can expect in the signal flow graph? Or examiner may provide the one question, signal flow graph. He may ask number of forward paths, number of individual loops, number of two touching loops. These are the expected questions. Now we'll discuss start. Okay, how to solve the overall gain shortcut technique here. Follow this technique, useful for both block diagram as well as signal flow graph. Now in the general I'll provide in the regular class. Here forward path gain in the numerator, 1 by individual loop gains. Loops are we have tried in the denominator part only. Loops we have tried denominator part only. But while writing individual loop means single. 3 also, okay, single 3, odd numbers. For odd number, I gave opposite sign. Opposite sign. For 3 also odd number, opposite sign, shortcut. For 2, even number means you have tried same sign here. Now this is a lengthy shortcut technique for okay. Now we'll apply this shortcut for the one question, signal flow graph question. Signal flow graph question here. Yes. Exams are asking C by R. Each one is note C by R of this question. Signal flow graph. Come on, try to do it. SFG. While sending the reply, SFG. Come on, do it. Follow the shortcut and yes, dear. Okay, fine. In fast mode, come on. Yes, I am going to solve this question here. I am going to solve here. First, what is the overall gain here? Overall gain equal to, now C by R equal to we need to write the forward path gained here. First path here, the starting input to output is called as the forward path here. So only 10 is there. 10, leave the space. Why? Because in the shortcut technique, leave the space here. Now 10, and any other forward path is there? Tell me. Input output. It is also forward path here. So 5. Second forward path is 5 here. Plus 5. Good. Leave the space. Generally that space you get 1 only. Now forward paths are completed. After forward paths here, we have to write in the denominator part loops here. One compulsory. Now loops here. Loops means, shall I write this one as a loop or not? Starting point, ending point same? Yes, loop. Now one opposite sign, while writing individual opposite sign, 10 into 2. 10 product of 2. This is the individual loop, loop 1. And one more loop is there. Here I will write the with a different color. It is also looped here. So this loop also minus sign is there. So what I can write? 5 into 2 here. Plus 5 into 2. Okay, 5 into 2. There is no concept of two non-touching loop here. There is no two non-touching loops here. Both loops are touching to each. So now tell me, first forward path passing through all the loops. When passing through all the loops, 1, delta 1. Second loop also touching both loops, 1 only. So this is nothing but 15 upon. Now tell me, 20 plus 10, 30. So 31 dear. Obviously option A is correct answer. In the regular class, we practiced it a lot on the based upon the shortcut technique. Powerful technique dear. By using this technique, we have done dear. Yes, many people are responded. Many people are responding. Shocking. There are many people responded. Very, very good. First student responded are Monica, A, Sanu, I think Sana, and Durga, Ram. Okay. Yes, many people are responded. Very good, very good. Now these are the question you can expect here. Now one more question here. Number of forward paths here. In this question, number of forward paths examiner is asking. Small modification here. These two are not touching here. These two are not touching here. These two are not touching here. Now I'll modify this question. Now, come and tell me number of forward paths in this question here. Yes, try to respond. Number of forward paths here. How many number of forward paths? Write down numericals. Number of forward paths dear. Yes, very good. Number of forward paths. Yes, tell me number of forward paths here. For this question. Yes. Now, number of forward paths, tell me dear. Yes, any answer? Now I am checking. 3, Ramesh. Hare Krishna, 3. Write down numericals. So 1, 2, 3, 4 like that. ABCD means I'll confuse. You are giving ABCD means that is the previous question or not. So give the number dear. So one student is aspirant D. Aspirant D. Okay, very good. Kalpana D option. Okay. Now there is a fighting between 3 and 4 dear. There is a fighting between Durga D, Jayasri B option. Option B Durga. Okay. Jayasri. Kalpana 4. Yes. Okay. Many people are responding, but we'll check it. There is a tough fighting between 3 and 4 dear. Now I'll check it first. Straight forward path. Number of forward path means input output. This is a one forward path, no doubt. One forward path completed. Okay, no doubt. Second forward path I am writing. This is second forward path. Second forward path completed. So I'll remove this two. Now I am moving to the third forward path dear. Third forward path. Is it third forward path or not? This is third forward path or not? Yes, third forward path. Third forward path. Now next to fourth forward path you observe. Here observe fourth forward path. Both are not touching. Okay, fourth forward path dear. Yes. So total number of forward paths are 4 dear. Once again I am teaching. Dear. Actually, already I told na, these two are not touching here. These two are not touching dear. Not at all touching. Now, okay, fine. Okay, one upon another. Now tell me. Yes, one by one. Straight forward path, I think no need to explain. Straight forward path, no need to explain. That is the first forward path. Second forward path, I think no need to explain. Now third forward path, I think you have the doubt. Third forward path here. Now all of you listen here. Third forward path. Here. This is a third forward path dear. Third forward path, observe. Now, yeah, this is the third forward path. Third forward path. Correct, accepted. Na? Now I'll remove third forward path. I'll go for the fourth forward path. I'll remove third forward path. Fourth forward path, observed here. This is the fourth forward path. Nowhere touching any node, touching all the node, touching only one time only. Wow, super. So total number of forward paths are 4, dear. So option D is correct answer. Option D is correct answer, dear. Now you can check it, check it, check it, check it. Many people are given, many people are given. Very good, very good. Wait, okay, now. Similarly, I am moving to the yes, time response analysis, dear. Time response analysis. In this time response analysis, what are the topics examiner is going to concentrate? There is a transient response, steady state response. In the transient response, basically they'll give the one trans function. They're going to ask what is the zeta, whether it is a undamped, underdamped, critical damped, overdamped based upon the zeta value. And also they're asking omega d value and okay, general basically asking zeta, omega and omega d and settling time, delay time, rise time, peak overshoot. That are the in the comes under transient response. Coming to the steady state response, steady state error, dear. Steady state error for ramp input, steady state error for step input, steady state error for parabolic input. These are the questions you can expect in this one. Now we'll discuss one by one question. Unity feedback system means H of S is 1. This is given. So design specification is that steady state error is given. For unit ramp input is 0.05 is given. Then the value of K is asking to find the value of K. These are the options here. These are the options here. Now these are the options here. Okay, fine. These are the options here. So first of all, for ramp input, here what is the input is given? Here input is given, unit ramp input is given. For ramp input, what is the steady state error? We have to find out here. For ramp input, we have to find out here. Let us. No RAM E, they are not touching here. All the nodes are touching one time only, dear. No, every node should touch only one time, dear. Okay, this one, come on, tell me. Yes, first of all, for ramp input, here for ramp input, unit ramp input, steady state error equal to, for unit ramp, what is the steady state error equal to? 1 upon kV, dear, velocity constant. What is given is nothing but, how much is given? Is given 0.05 is given, dear. Given 0.05 is given. 0.05 means 5 by 100, dear. That is 1 by 20 is given. Okay. Now what is the kV equal to? Now kV, from this one kV equal 20. What is the kV equal to, dear? kV equal to limit s tends to 0, s product of g of s, h of s. H of s is given 1. Now proceed, kV equal to limit s tends to 0, s product of, what is the g of s is given? This is g of s is given. K upon s into s plus 2, na? S plus 2. H of s is 1. That is nothing but kV is given how much? 1 by kV equal to 1 by 20. So kV equal to 20 only, dear. So 20 only. Wherever the s is cancel, here s is cancelled here. Wherever s is there, 0 only. So finally what happens here? K by 2 equal to 20. So no doubt K equal to 40, dear. So perfect answer, K equal to 40, dear. So how many people got it here? How many people got it here? Wow, good. So here option B, Sana, okay, you got it. Monica, right now you got it. Wow, good. Now one more question we'll observe here. Okay, same. Let us one question here. Yeah, this is a okay steady state error based upon the steady state error questions here. Now, okay, fine. Steady state error constant Kp, Kv, Ka is asking. What is the g of s? What is the h of s is given? So, dear, Kp equal, what is the formula for Kp? Kp equal to limit s tends to 0, g of s, h of s. So, limit s tends to 0, Now g of s, this is g of s here, 10 by 10 upon s into, tell me, s plus 1, s plus 1, s plus 5, h of s is 1 by s, 1 by s. S tends to 0, wherever something, s tends to 0, something by 0 is how much? Infinity. So first one should be infinity. First one should be infinity means first one is 0, wrong. First one is 0, wrong. First one is 0, wrong. So first one is infinity, only option is C. No, I'm going to find KV also, don't worry. So KV equal formula is what here? KV equal to same limit s tends to 0, g of s, h of s. But instead of g of s, h of s, here, yes, you will get limit s tends to 0, s product of same 10 by s into s plus 1, product of s plus 5, product of, okay, h of s. Now this is cancel, s tends to 0. Wherever s tends to something by 0 is infinity only. Now next K, A is asking acceleration constant, positional constant, velocity, acceleration, that same formula, limit s tends to 0, same only, g of s, h of s. So Kp means s power 0, s power 1, and s power 2. S power 2 means, come on, tell me, limit s tends to 0, s product of 10 upon s into s plus 1, s plus 5 dear. Okay, product of 1 by s. Now come on, actual s square, okay. 1 s square, this is cancel, 1 s cancel. So wherever s is there, 0, 0, 10 by 5 equal to 2 dear. So obviously option C is correct answer dear. Option C is correct answer, okay. How many people are responded now? We'll check it. Yes, yes. Option C is right answer dear. Now till now I did not receive any answer. Yes, I did not receive any answer. Yes, Sadia Khan. It is a GENCO Transco control system syllabus dear. It is useful for all the states. Okay, don't control systems, it is a. Yes dear, now nice. Now I think no one got it. Option C dear here. Option C. Simple question. Now then we'll go for one more. Yes dear. Stability analysis using Routh-Hurwitz method. In this one examiner is asking stability. Means you'll give the characteristic equation, then ask that to find the number of poles right side, number of poles left side. That is the one thing. And also frequency of oscillation. And the theoretical question, when the poles are repeated on imaginary, what happens? When the poles are non-repeated on imaginary, what happens? That type of questions are asking in the RH method here. Okay, fine. Okay, fine. Yes, fine. One question we'll discuss. Which of the following system is stable here? Which of the following system is stable? Come on, tell me. Stability related. Yes, everyone should respond. Everyone should respond. Now, which of the following system is stable? Generally, we have to use our RH method table, but not required. Simple logic here. Simple logic here. Now, in the characteristic equation, all signs should be have the same sign. It is a positive. It is a negative. Sign has changed in the characteristic equation, hence it is unstable. Here plus symbol is there, here minus symbol is there. In the characteristic equation itself, sign change, so unstable. Here power 4 is there, power 2 directly jumped. So power 3 here, missing up term, missing term. Any term is missing, then the system is unstable. So no doubt from this option, second order system always stable here. So no doubt option A is correct answer. Yes, Durga, how many people are given? Sana, Monica, Sana is given first student, Monica second, and Durga, very good, very good. Simple logic we have to play here. Simple logic here. For stability, in the characteristic equation, no sign should not be changed, that is the first thing. And all the coefficients should be present, all the, okay, S power 4, S power 3 term is missing, all terms should be present. So obviously, okay, option is stability system here. Then next we'll go for one more question. The number of roots in the equation, characteristic equation is given that lies in the right of S plane is. Right of S plane means number of sign changes here. Number of sign changes in the question here. Okay, I am taking here number of sign changes here. So first thing, how many sign changes in the right side? Now S power 4 dear, S power 3, S power 2, S power 1, S power 0. How many sign changes will observe? S power 2, okay, 3, then 7, then 1, then 5, 0. 3 minus 10, it is a minus 7, okay, 7, 0. Minus 35 minus 7, minus 42 by minus 7. Minus minus cancel, 42 by 7. So 7, 6, 6, 0. This is 7 dear. Now come on, help me here. Positive, positive, only sign, 1 change, 2 change. So positive to negative 1 change, negative to positive 2 change. There are 2 sign changes, hence right side poles are 2 dear. Number of sign changes are 2. Right side poles equal to also 2 dear. Right side poles equal to number of sign changes in the first column. So based upon this one, answer option C is right answer dear. How many people are given? Very good. This type of questions you can expect dear. Okay, very good. Now, so okay, in the chapter, now, yes dear, root locus. In the root locus, examiner is asking, especially GENCO, transco point of view, very low level question. Number of asymptotes, angle of asymptotes, and breakaway point. Actually, it is a 2 marks question. But breakaway point means no need to find the breakaway point by using regular method. Simple logic we have to follow. How to find out the break point here, we will observe here. Root locus question. And also to find there are 2 conditions are required in the root locus. Angle condition, magnitude condition. Angle condition is required to find whether the given point is on the root locus or not. Magnitude condition is required to find the system gain K. So what are the questions, some of the expected question? The breakaway point of the question, okay. So don't write the complete, no need to follow the procedure. Why? Because in the GENCO transco point of view, you have the just 40 seconds only. In 120 minutes, almost all you have to solve the 100 questions here. So only you have the 2 hours now. Very less time. Approximately you have the 1 minute only. 60 seconds. Approximately 1 minute you have. To find the break point, regular method it takes the 2 to 3 minutes. How to find? Now these are the poles and zeros. Let us I am locating the this is explained here. Now I am locating S equal to -2, there is a pole. S equal to there is a -2, there is a pole. And S equal to -5, there is a pole. And S equal to -10, there is a 0 dear. First, what are the root locus points here? Number of, here this side, total number of poles and zeros are odd number. So it is on the root locus branch. It is not a root locus. Why? Because 1 to even number. It is not a root locus branch. So, okay, fine. Now, yes, always one condition break point compulsory on the root locus branch only. On the root locus branch means, so, yes, the break point compulsory break of these 2 poles must exit from, break the relation with the real axis. So, compulsory break point should exist between -2 and -5. It is not between -5 -10. Why? Because break point never be on the not a root locus branch. Always break point compulsory on the root locus branch only. Break point, breakaway point must lies on root locus branch. On root locus branch only. Based upon this concept here, so obviously between -2 and -5. So between -2 and -5. So no doubt between -2 and -5, no doubt option D is correct answer here. Option D is correct answer here. Sir, break point happen between 2 poles. Is it correct? Yes, correct. Durga Prasad Chari, correct. You are super. Yes. Goni Kalpana, yes, correct. Option D. Very good. This type of question we can from basics here. Yes. Next to whether the given point in the S-plane lies on the root locus can be determined by using. Whether the point is exist on the root locus or not can be determined by using angle condition. So angle condition. To check whether the point is on the root locus or not, we can check by using angle condition. This magnitude condition used to find system gain. Used to find system gain. That is a system gain here. There are 2 conditions are required. System gain K. To find the system gain K, we require magnitude condition. Whether the point is exist on the root locus or not, we require the angle condition here. Okay, this type of question we can expect. Now, yes dear, Bode plot. So frequency domain started. Frequency domain started now. Bode plot here. From the Bode plot, basically examiner is asking classification of the system, whether a given system is minimum pays or non-minimum pays or alpha system. Once again, I'm repeating, whether the given system is minimum pays or non-minimum pays or alpha system or inverse Bode plot directly asking. They're providing one Bode plot, they're asking trans function, that is the inverse Bode plot here. So I'm going to provide the some of the rules of the inverse Bode plot here. If initial slope is important first point, if initial slope increases, then S term present in the numerator. Reverse case, if initial slope decreases, then S term present in the denominator. If initial slope no increase, no decrease, like constant like this, constant, then no S term in the numerator and denominator. Okay, based upon this one, we'll observe one question here. Yes, this is a Bode plot here. Is asking trans function of the system. What could be the trans function of the type? Trans function of the type here. So I am going to solve here. Yes, this is a Bode plot. First one, trans function equal to, that is the trans function g of s, h of s equal to. Initial slope, initial is how much? Come on, tell me, minus 20. Shall I write this minus 20 product of 1? Yes. Minus indicate there is a S term. Initial slope is decreasing, means there is a S term present in the denominator. K. S term present in the denominator. Why? Because initial slope, this minus, if it is minus means initial slope present in the denominator. If it is a plus increases means S term present in the numerator. So generally initial slope indicates the type of the system here. Type of the system. Type indicates poles at origin here. Okay, good. Now next at 2, corner frequency at 2, it is a 0 dB. 0 minus of minus 20. The procedure 0 minus of minus 20. That is nothing but plus 20 product of 1 here. Plus means we have to write numerator with the corner frequency 1 plus s by 2. 1 plus s by 2. Okay, n by 2. Now here if you write here, next frequency 20 minus previous slope is 0. So accelerate plus 20 product of 1. 1 means that power is 1 only. Power is 1 only. Plus numerator. So corner frequency 1 plus s by 10. This is a trans function here. If you convert into now k, s plus 2. Sir, I write the 2, sir. S plus 10. 10 into 2, 20. K by 20 also. We can write constant s only. So this is of the form here. No doubt option B is correct answer. Anything 1 by 20 something constant into constant k only is written. So best suitable option is given option B dear. These are the questions from the Bode plot here, expected question. Wow, many people are given here. Option B. Kalpana given, Sana is given, Durga Prasad, okay, Ari Krishna. Wow, all people are given correct answers here. All people were given correct answer, very good. Feeling happy. Now, very good response from the students. Now, let us, 1 hour is not sufficient. Keep on teaching, even 1 month also not sufficient here for me. But within the given stipulated time, I have to cover all the topics, important topics. Now, yes, initial slope of the Bode plot gives. Initial slope means what dear? Initial slope. This initial slope indicates what? Come on, tell me. Because of initial slope, we have written this S. Number of poles at origin indicates the type of the system dear. Number of poles at origin indicate type of the system. So from the given option, type of the system. Initial slope indicate type of the system dear. Good. Initial slope indicates type of the system. Yes. Which of the following trans function is a non-minimum phase system trans function? Non-minimum phase system means 0 should be right side here. Okay, 0 should be right side. 0 minus 1 left side. 0's left side. S equal to minus 1. Only 1 0 is right side here. 0 for this one is right side. When 0 is right side, that system is called as a non-minimum phase system. Okay, this is a non-minimum phase system. No doubt option D is correct answer. So, minimum phase system means all poles and zeros should be left side. Minimum phase system means I'm writing minimum phase system means all poles and zeros in left side. Non-minimum phase system means at least 1 0. Non-minimum phase system means at least 1 0 right side. At least 1 0 at right side. At right. That is a non-minimum phase system. Okay, these are the questions you can expect from the Bode plot here. Yes, Nyquist plot. Nyquist plot, what type of questions will get Nyquist plot here? Yes. Yes. What is the Nyquist plot questions here? Let us. This is a polar plot of the polar plot is the thing about Nyquist plot same only. This is a given trans function. For this trans function intersect the origin. So these are the options here. These are the options here. First of all, it is a type 1. Number of poles at origin indicates types. Type 1, order 2. So how to draw the plot here? Polar or Nyquist, how to draw? It is a type 1, order 2 here. So here, polar plot start at type, polar plot ends at order. Now, yes, type 0 means you have to start white color here. Type 1 means here, type 2 here, type 3 here. Order 1 means ends here, order. So the given system is what? Come on, tell me. It is a given system is a, it is a type 1 here. It is a type 1 here. Why? Because number of poles at origin is 1. Total number of S terms here 2. Order is 2 dear. Order is 2. So type 1 means where the type 1 start? Come on, tell me. Type 1 start here only. Type 1 start here parallel. Where order 2 ends here? Order 2 ends here only. So order 2 ends here only dear. Order 2 ends here only. This is a polar plot here. Now tell me, is it crossing minus 180 degrees line? No. Is it crossing real axis? Is it crossing imaginary axis? No. It is not crossing real axis. It is not crossing imaginary axis here. So best suitable answer is what? Come on, tell me. It is not crossing. No. Neither the real axis nor the imaginary axis. It is not intersecting. It is not intersecting imaginary axis or real axis. If you want, it is. If it is crossing like this means it is crossing real axis. If it is crossing like imaginary axis means crossing both real and imaginary. But it is not crossing, white color observe, white color observe. It is not crossing either real or imaginary. So this type of question you can expect here. This type of question you can expect in the polar and Nyquist plot. So time is very less, okay, within the time limited stipulated time. Now, okay, now just to better point of view, in this one, what are the important points also I am providing? Nyquist stability criteria, just to theory point. If the number of encirclement with origin means this is a formula here. What is a P, Z I am providing? If the question is number of encirclement with respect to -1 plus J0 encirclement, then what is a N, what is a P, what is a Z here also? Just to try to learn this formula. Now Nyquist stability criteria. Then, okay, these are the expected question in the chapter. Expected question here. Yes, compensators and controllers. Compensators and controllers. Okay, when PD controller is used in a system, what happened? Natural frequency affected, damping ratio affected, type of the system affected, steady state error is affected. So come on, tell me. Okay, Monica, if time permits, I'll do the Bode plot and polar plot here. That required 5 hours dear each chapter. 5 hours is required. No, okay dear, Monica. If I, okay. Yes, if time permits, I'll do it dear. Don't worry. Now, PD controller, come on, based upon this one, all the points related to the PD controller I am providing here nicely. Yes. Yeah, dear. Okay, all the points related to PD controller. If you use a PD controller, no effect on the type of the system. And steady state remains unchanged. First point. So type is no change here. No change here. Type is no change. That is which is affected. No change. No effect. No effect. This is a no effect. Hence steady state error also unchanged. So it is also no effect. If you use a PD control, no effect. Now, next, omega n value, no effect on omega n value. Sixth point observe, no effect on omega n value. No effect on omega n value. No effect on omega value. No effect. Now, okay, no effect. Now, next observe, damping ratio. Yes, third point observe, damping ratio. Third point, increase the damping ratio here. Increase the damping ratio here. Increase the damping ratio. Yes, it is affected. Damping ratio is affected. So it is affected. It is affected. So examiner is asking which one is affected is asking. So obviously option B is correct answer. How many students were given? Monica is given. First student. Sana is given. Second student. Kalpana third. And Anita. Okay. Hare Krishna, sorry, you given wrong. Okay, fine. So once again, read it. Just I'm showing the effects of PD controller. Note down effects of PD controller. Yes, dear. Let us effects of PD controller. Come on, note down. Note down. These are the main points about the PD controller, dear. Reverse of this one, PI controller. Let us one more point. Lead compensator, lag compensator. Hello, dear. For lead compensator, this is a lead compensator trans function is given. For lead, the numerator part is less than denominator, that is comma, that become lead here. For lead, numerator become less than denominator. For lag, numerator greater than denominator, then it become lag here. Now, okay, which of the following is the options are correct? Come on, tell me. A less than B, P greater than Q. So no doubt option A is correct answer. It is also most expected question here. Most expected question. Now, yes, dear, fine. Trans function. Now, next point here. Next point. Yes. Which of the following compensator is used to increase the speed of the response? Lead compensator, lag lead. Okay, lead. None of this above. First of all, we'll discuss what is the lead compensator properties here. Speed. So first thing here, observe. Yeah, nice. Lead compensator points here, observe. Third point, rise time decreases, sensor system gives a faster response. Improves the speed of the system in the bracket. So which one? Tell me, which of the following? So, okay, lead compensator. Opposite these points is the lag compensators. So which of the following compensator is used to increase the speed of the response means no doubt. So no doubt lead compensator means. So once again observe the points about the lead compensators. The points about the lead compensators here. Yes, good. Option A, very good. Many people are given. Now again, Monica is given first too. And yes. Anita, second. Ruchita. Durga, Sana, very good dear, very good. Next, these are the effects of the lead compensators here. Now, okay, fine. Next to state space analysis here. We'll observe the state space analysis. Now, in this chapter, mainly controllability and observability, very important. Controllability and observability. I'll add the formula for controllability and observability. Controllability means MC. Controllability, very important. B, A, B, and so on. A square B and so on like this. For controllability, det of MC not equal to 0 means it is a controllable. If it is equal to 0 means not controllable. This is a controllability formula here. Controllability formula, expected question, controllability formula. And observability, there is a one more formula is the observability. M not equal to, there are two formulas here. C transpose, A transpose, C transpose and so on. There is a one formula or reverse. C, CA and so on like this. For if det of M naught not equal to 0, then it is a observability. So try to practice observability, controllability. Okay, most expected in the control system. Control system is controllability and observability. Most expected question, controllability and observability here. And one more state space analysis also there, dear. State space analysis, state transition matrix also there. State transition matrix also. There is one more question is called as a state transition matrix here. A state transition matrix of the system is, okay, these are the options here. These are the options here. Okay, fine. How to find the state transition matrix here? Either observe. State transition matrix means we need to use the formula here. First thing, state transition matrix means we need to use the formula. State transition matrix, that is a pi of t equal to e to the power of at equal to L inverse of Si minus A inverse dr. This is the formula for state transition matrix. But if you use this one, more time it takes. It is observe one shortcut, one of the sweetest technique here. It is all or diagonal matrix. For diagonal matrix, simple state transition matrix means e to the power of 2t, e to the power of 2t dear. Simple. E to the power of 2t plus only. So no doubt option B is correct answer dear. Once again I am writing, once again I am teaching, once again I am teaching here. So best method. This is a regular method here, regular method. Now simple shortcut here, simple shortcut. If the diagonal matrix is there, simple e to the power of 2t, e to the power of 2t, whatever the sign is there. So no doubt option B is correct answer. No sir, if it is not diagonal means what is the method you have to use? This is a regular method here. This is a regular method we have to use. This is a regular method. Good. Okay, dear, within the time I covered all the concept here, almost all expected question here. Within 5 minutes, now once again, before ending, I'll do the one more motivation here. Now, already you are selected to write the government job. Telanganalo government job. So, why government job? Endu government job kavala? Stability, security. More stability. Even, okay, because of corona, you got an experience. Private job, what happened? So many companies close అయిపోయినాయి. So, not one corona, one side నుంచి corona, one side నుంచి tsunami, one side నుంచి, okay, anything if effect, every month I want a salary means go for government job. So, government job, that is your, okay, now you are selected, very nice. AE, you are writing. So, what is the best motivation for this one? If the path is beautiful, so ask where it leads to. Your path is very beautiful. Okay, you want government job, na? Now, if the destination is beautiful, never mind the path here. Your destination is government job, dear. Never mind the path here. While traveling, you will get the so many pains, psychologically, physically, okay, emotional, and also financially. You face a lot of problems. Don't worry. Don't give up, dear. Your destination already, you know, government job. With every month, I want a salary, stability. I want life, the stability, na? So, in my word, if you want contrasting language, okay, I want stable life. For stable life means destination is government job. So, never mind the path, dear. In the path, whatever the problems you'll face, don't give up, dear. So just I given 1 hour about the valuable information, about just 2 minutes about the ACE Academy. Now, okay, keep walking, dear, keep walking, rock. So in the preparation, try to reduce using the social media, dear. I'm not asking completely avoid, only use for social media, knowledge purpose, up to government job. After getting 24 hours, you can use, no problem. But up to getting the job, just to use for social media, dear. These are the simple tips here. Now, okay, fine. Mode of classes in ACE Academy. First one, physical classes. Now, right now, classes are running. Now, second one is live classes, online. Now, live class. Second one is pre-recorded videos. So, all classes, including control system, all subjects are available. Pre-recorded means at any your convenient time, you can listen. And postal coaching means materials, dear. Now, okay, these are the materials we can supply, we'll supply. Okay, fine, dear. Let us. If you have any doubts regarding any general or subject doubts, anything, we can approach. This is a mail ID, dear, Gnani412. Okay, this is a, if you want more videos, you can search Gnaneshwar Sir control system. Okay, fine. Any doubt or anything, if you want more videos, search in the YouTube, Gnaneshwar Sir control system. Okay, dear. Yes, within 1 hour, I covered. I hope this session you are enjoyed, okay? Helpful for your preparation, no doubt. Now, dear, only from my side, last word, only blessings. Now, dear, don't stop. Okay, don't stop when you are tired, dear. Stop when you are done. So, all the best, dear.